Good morning everyone. I am Anbu Shamani from RFM College of Engineering and Technology. Today I am going to take the topic solving differential equations using Laplace Transform from signals and system. So what is meant by differential equation? Normally a differential equation is one which relates the input and output of a linear time invariant system, that is LTI system. So the response of this LTI system is obtained by solving this differential equation. When we solve the differential equation, we will get output response, steady state response, input response, etc. Here, Laplace transformation technique is used for solving this differential equation of an LTI system to get that responses. Now, let us see the differential equation. In this slide, it is given that an nth order differential equation is given by summation k is equal to 0 to n ak d power k into y of t by dt power k, which is equal to summation k equal to 0 to m bk d power k into x of t by dt power k, where this y of t, which is in the left side of the equation, denotes the output and x of t denotes the input of a system. Now the ak and bk denotes the coefficient constants. Now, how we can solve these differential equations using Laplace transform? Here are the procedures which is given to solve the differential equation using Laplace transform. First, we have to apply the Laplace transform to the differential equation. Then, if initial conditions are given, we have to substitute the initial condition. Then, we have to perform algebra to solve for the output or variable of the interest. Then after applying the algebra like partial fraction and all, we have to apply the inverse transform to find the solution. Now, what are the terms needed to find while solving this differential equation? As already I have said, x of t be the input signal, y of t the output signal, and h of t be the impulse response. Now, the response y of t of a continuous time system is given by convolution of input and impulse response, that is y of t is equal to x of t convolution h of t. Now when we apply Laplace transform, this y of t becomes y of s and x of t becomes x of s and h of t becomes h of s. As we all know, that is convolution in time domain is equal to multiplication in frequency domain. So, y of s is equal to x of s into h of s. From this equation, h of s is equal to y of s by x of s. That means we call this h of s as transfer function, which means the ratio of output of the system to the input of the system, we call it as transfer function, and it is the main function of a system while solving the differential equation using Laplace transform. Now we are going to study about selected Laplace transform, that is for solving the problem we are in need of Laplace and its inverse. For example, if f of t is equal to 1 and its Laplace transform is 1 by s. If the f of t is equal to e power minus at, its Laplace transform is 1 by s plus a. And if the Laplace transform is s by s square plus 1, then its inverse is cos t. Similarly, if f of t is equal to sin t and its Laplace transform is 1 by s square plus 1. There are lot more number of Laplace transform, but for our reference, I am given totally 4 types. Now we are entering into a problem. Here the problem given is, for the system described below, find the system transfer function. And the question given is d square y of t by dt square plus 11 dy of t by dt plus 24y of t is equal to 5 dx of t by dt plus 2 3x of t. So how we are here, the differential equation is of order 2 because d power gives the order of the differential equation. Here d power 2, so second order differential equation. Now we are going to solve this equation. As we all know, here no initial conditions are given. Then for the Laplace transform of a differential function is equal to s power n into y of s. That is, the Laplace transform of nth differential function is equal to s power n into y of s. Using that equation, here I am going to rewrite d square y of t by dt square as s square into y of s plus 11 into dy of t by dt as s into y of s plus 24 y of t as y of s, which is equal to 5 dx of t by dt as s into x of s plus 3 x of t as x of s. Now in the second line, we are going to combine all the y of s terms, and taking y of s common outside, we will get s square plus 11s plus 24. And in the right side also, I have taken x of s as common. The rest term is 5s plus 3. Now, as already I have said that, we know that transfer function h of s is equal to y of s by x of s. Now, cross multiplying it and making it into a term, y of s divided by x of s, we will be getting 5s plus 3 divided by s square plus 11s plus 24, which is the transfer function we have needed. Now we are moving on to the next problem. Find the output response of the system with the transfer function h of s is equal to 1 by s plus 0.5 and s plus 1 for a unit step input. So here the transfer function is directly given, not the differential equation. Here the transfer function is directly given, and unit step input is also given as a unit step function. So we have first I have written the given, that is transfer function h of s is equal to 1 by s plus 0.5 into s plus 1, and the second given function, that is unit step input, that is x of t is equal to u of t. Now applying Laplace transform to the unit step function, x of s is equal to 1 by s. Now we know that h of s is equal to y of s by x of s. From this, y of s is equal to h of s into x of s. Already we have h of s, we have x of s. Substitute here. So what we will get is y of s is equal to 1 by s plus 0.5 into s plus 1 into 1 by s. That is our y of s. Now the next step is we are moving on to algebra, that is we are going to apply partial fraction for this function, that is 1 by s into s plus 0.5 into s plus 1, which can be written as a by s plus b by s plus 0.5 plus c by s plus 1. As we all already know about partial fraction, I am not going to explain briefly about the partial fraction. We all know substituting certain values and we can able to calculate a, b and c. Now in my own way, I have calculated the partial fraction, that is 1 is equal to a into s plus 0.5 into s plus 1 plus b into s plus 1 plus c into s plus 0.5. Now substituting s is equal to 0, I have got a equal to 2, and substituting s is equal to minus 0.5, I have got b is equal to minus 4, and substituting s is equal to minus 1, I have got c is equal to 2. Now I have collected all this, I have got the value of a, b and c, and I have substituted this in this first equation, that is a by s, where a I have substituted 2, b by s plus 0.5 where I have substituted b as minus 4, and c by s plus 1 where I have substituted c as 2. So this is my equation. Y of s is equal to, after substituting a, b and c, 2 by s minus 4 by s plus 0.5 plus 2 by s plus 1. As I have already told in the procedure, the next step is to apply the inverse Laplace transform. Now I have applied the inverse Laplace transform. So y of s becomes y of t. 2 into 1 by s becomes, that is u of t, minus 4 into 1 by s plus a can be written as e power minus at into u of t. Likewise here it is 1 by s plus 0.5. I am writing it e power minus 0.5 t into u of t plus 2 into 1 by s plus 1, which can also be written as e power minus t into u of t. Finally, I got the answer. I have taken all the u of t term outside and I have got the answer. Y of t is equal to 2 into 1 minus 2 e power minus 0.5 t plus e power minus t into u of t. So once again revising that to find or to solve a differential equation, we have to apply the Laplace transform, then we have to apply the partial fraction, then we have to reapply the inverse Laplace transform, and we will get the output response or step response or input response of a system. I think you have understood this problem and you have understood the topic with this example. Thank you.